All right, last lesson of chapter 2. And in terms of algebra difficulty, I would say it's on the low end, not very difficult. As long as you can read words and make it into an equation. So all I'm going to do is try to simplify the process as much, and then we just got to jump in and work problems. So I'll go through what each word kind of stands for as you're reading, and then I'll explain to you how we set up an equation, and then go into, once you get the equation, that's the easy part. Okay, so for instance, so the word directly. So if we're reading a statement, so what I'm going to do is I'm going to write a statement out with each one of these words and then explain to you how we would relate the two, what it means. So the first one, let's just say, I'm just going to do an example. Example 1, convert from words to an equation. Okay, so the first one here, directly. What it means is this: when you're reading a statement, so let's say the statement is y varies directly with x. It means that the way y and x are related is that they're proportional to each other. Okay, so let's say when x is 10, y is 2. When x is 20, y is 4, and so on. But really, what I know is this, is that the way I write the equation, when I see the word directly, I'm going to do a constant, an unknown constant, we call it the constant of proportionality, times x. So when I see the word directly, my equation will look like this: y equals k times x. And this k is just it's called your constant of proportionality. And I'll show you why we might need that. You know, a typical problem. So it's just it just depends on the problem. So I'm going to give you a problem here in a second where, okay, as x is increasing, so is y, but at what rate, are they related? That's where this multiplier comes into play. But the key word you need to see is that when we see y varies directly with x, we're giving you the left-hand side variable, the right-hand side variable, and how they're connected. So had I written the statement like this, y varies inversely with x, you're still going to have some proportionality multiplier, but it would be y equals k over x. You know to then take that, when you see the word inversely, you're going to take your second variable and put it in the denominator. It won't always be y's and x's. It could be, c's and time and whatever. But again, whatever is on the left here goes on the left-hand side, varies however with whatever. That's my other variable. If it's directly, there is no fraction. If it's inversely, it goes in the denominator. And there's always a k, a multiplier that I use. So what I think is best is we just get into like a typical problem and solve it and see that the actual working the problem is not that hard. And then I'll talk about jointly in a second. Okay. So I wrote a typical one down. So we'll call this, so I do know I got to do jointly in a second, but let's do directly first. So example 2. So here's what something would look like. An alligator's tail length, T, varies directly with its body length, B. So you can see now I've given you the two variables. And there's some multiplier, right? Because think about it, they're not going to be equal. I hope the body length of an alligator and the tail length are not the same. So they're not exactly equal, but they're proportional to each other, right? So let's think about it. Think about an alligator, right? If its body length is 7 feet Probably its tail length is what? Maybe, what do you think, longer or shorter? A little bit. A little shorter, but they're not going to be the same. But how much shorter? Well, there's a linear relationship according to this problem, right? Then what else do we need? So we're going to need something else, you'll see. So an alligator with a body length of 8 feet has a tail length of 4.5 feet. What is the tail length of an alligator with a 10-foot body length? Okay, so I'm going to show you how we work this problem in stages. Okay, first thing I'm going to do is just write out how T and B are connected. Okay, so I use the same example that I've been using over here to the left. Is it directly or is it inversely? Directly. You read the words. T varies directly with B. So first of all, what equation can I write? Now, listen to me. It works in stages. The first stage is I write an equation like this. It's either the top one or the bottom one. That's exactly what you do. That's the first step. You first just write out the equation relating T and B, and there's a constant of proportionality. So stage one is you write out the equation. It's either the first or the second, and I'll show you jointly in a second. So here I work this, then I use this, then I find this. So there's 3 parts. We're going to do this first. What does this mean? T equals K times B. That's it. You need to be able to read the words and write the equation. Don't do too much at once. So typically, when you have an equation, you don't have like an extra little, you don't have an extra little constant here. Usually this is a number. It's 2, it's 7, it's something. Y is 7x. Y is 14x, whatever. So we've got to solve for this. This kind of tells us how, because look, as the body grows, the tail grows. As the body grows, the tail grows. So what it is there's some proportionality there. We got to figure out kind of what's the multiplier, okay? All right, so now what? So let's see. So an alligator with a body length of 8 feet has a tail length of 4.5 feet. So now, what do you think this is used for? To find K. So the next thing we're going to do, so step 1, what did we do? We write the equation, whatever it is, just going from words to letters. Step 2, use info in the problem to solve for K, because you need to find that constant. It's how those 2 variables are connected. Okay, so that's what I'm going to do. I'm just going to plug in. When, let's see what it say. When B is 8, tail length is 4.5. So I'm going to do 4.5 equals K times 8. Make sure they go in the right spots. Okay, and then you're just going to have to figure out what K is. So you can use your calculator and get a decimal if you want. So now you just solve for K. So K is 4.5 over 8. I wouldn't leave it like that. Either make it a fraction or make it a decimal. The fraction is 9/16. Or get the decimal. What's the decimal?
0.5625.
0.5625. That's fine too. Okay? I don't know which one to calculate or the math lab. Again, how did I get this? 4.5 is the same as 9/2, and then I just dropped the 2 down there, 9/16. Okay, so either way. All right, now I now can improve my equation. Now that I've solved for K, now I know that the tail length is 0.5625 of the body length. So it's just basically telling us it's about half of the body length, right? Not a little bit more than half. So if you know the body length, you can get the tail length. That's it. And now you found your equation. All right, so there's step 2. Now step 3 is just plug and crank, right? Now you just plug in and solve. So now what am I looking for? I'm trying to solve for what when what is what? I'm solving for tail length, which is normally what we get as long as I know the body length, which is how much? 10. So you just plug in. So what's the tail length when the body length is 10? And what do you get? Yeah, 5.625 feet. That's a big alligator. I made all this up, by the way, so I don't know how legit it is. Okay, so the alligator, that's 15 feet. So like from head to tail, right? So let's see, 15 feet would be 15 of these blocks. So let's see if that makes sense. Is that real? Is that like for real or is this prehistoric? 1, 2, 3, 4, 5. I think that's real. Yeah. And that's why I don't go near lakes or ponds when I'm in Florida. I don't want to be his breakfast. Okay. All right. So, but kind of creepy working this problem, but you get the idea. So there's always, and when it's the full-blown word problem, this is like the max that you're going to do. A lot of it might just be, well, just write it out. If you know, whatever, it could be A's and B's, it could be anything. All right. Now, if it uses the word jointly, then there's 2 things on the right hand side. So let's see, it could be a third sentence here. A third one could be this. We'll use part C. C varies jointly with P1 and P2. Okay, so if I see that, not joints, jointly, C varies jointly. So again, it's telling me my left-hand side and how to write my right-hand side. Okay, it's always multiplication or division on the right-hand side. And what do we use for our constant of proportionality? Okay, so there's 2 things on the right that influence the one on the left. So the way this equation will go, and again, this is just your step 1, C equals K times P1 times P2. So jointly means you multiply both of those, and then you put your constant of proportionality. So you'll just need to refer back to these as you do them. Directly, you multiply. Jointly, you multiply, there's 2 of them. And inversely, you put the variable on the bottom. K always stays in the top. It's just a constant once you solve for it. Okay? All right, what if I had part D, C varies jointly with P1 and P2, and inversely with the square of A. So see if you can write that out. That's all one equation. Okay? All one equation. C varies jointly with P1 and P2 and inversely with the square of A. That's an A, by the way. Looks like a cube. I'll tell that away from it. So that's just one equation. What's on the left-hand side? What's on the right-hand side? How do you write the right-hand side? Don't forget, there's always a constant of proportionality. Okay. So, anybody want to take a stab at it? What goes on the left? C equals, what's the first thing I want to write? K times what? Times P2, that doesn't change. Didn't say square root, yeah, of a squared, all over a squared. So when you see the word inversely, you're going to introduce what? Fraction. But it's all multiplied and divided. There's no plus, there's no minus, and then there you go. All right. Now, what would you need in order to solve this? So like, for instance, what information would you need? A and no, normally you solve for K first. So you need what? C, P1, P2, and so when P1 is 1, P2 is 2, A is 4, and C is 10, well, then you can say, then it's find K. First find K, and then use this to find C when P1 is 4, P2 is 8, A is 3. All right, so you can do that. Always you solve for that constant of proportionality first, unless it gives some other kind of instruction, and then you plug in. We've already done step 1, right? We've already written the equation, so you don't need to do that again. It's really just a lot of plug and crank, honestly. But if you can't read the words and get the equation right, then it's going to be the wrong plug and crank. Okay, so let's have a look. So I've got my equation, and I've got to solve for my constant of proportionality. Really, P1, P2, A, and C are all my variables, okay? So if you plug everything in here, you may need a calculator. C is 10, P1 is 1, P2 is 2, A is 4, so that's 4 squared. So this became 2/16, which is 1/8. So you should have got what for K? 8, right? So 10 is K over 8, right? Because this right here, cross multiply, 80 is K. So once you find your K, K is always 80. Now you go back and now you've got your real equation. Now this is the real equation. Now you just need these unknowns, whatever they are. I don't know what this equation represents. I'm just making it up. And now, so now look, now I'm looking for my output when all these are my inputs. See, still goes back to input output. So now let's see, 80 times P1 is 4, P2 is 8, A is 3. So that's a 9 on the bottom. So you just got to do the math there, whatever. I don't feel like doing that. You can help me. What's the answer? Type it in. 80 times 4 times 8, 320, 24. Goodness, man, miserable.
Not 284, 24.
Anybody else? All right, good. All right, does that make sense on how we're working that there? Any questions? Okay, so I'm gonna give you another word problem, see if you can do it. Okay? Directly, I'm gonna read it, you're gonna give me, I point to somebody, give me the equation. Y varies directly with X. X. Y equals K times X. Okay? T varies inversely with J. That's right. Everybody got that one? Inversely, you put so what do we always gotta add to the problem that's not in there? What's the one letter? The K. And they should make you use K. V varies jointly with M and N. So V equals K times M times N. You might have half the alphabet on the board, but everybody got the 3 words. Directly, you just K times. Inversely, K over. Jointly, K times again. And if it's jointly and directly and inversely all in one, you put them all together. Okay? Like that one. All right, here we go. Example 3, I guess. Okay. The distance, this is example 3. The distance S that a body falls from rest varies directly as the square of time. T of the fall. If skydivers fall 64 feet in 2 seconds, then I'm going to leave this a blank. So part A, write the equation with K in it. Part B, solve for K. Part C, then how far will a skydiver fall in 4.5 seconds? You can do that one. So notice it's giving you your variables, it's giving you how they're related. I've given you some information where you can solve for K. So again, these are the steps. Write out your equation with your variables, then solve for the constant of proportionality, then find whatever it's asking you to find. Got it? Easy. So let's see, Zoe, what did you get for just the basic equation with the letters? What would that be?
S equals KT. K times.
Square of times KT squared, right? You gotta do K times squared. Everybody agree with that? Okay, so make sure that you look closely when you're writing those, okay? But it was the word directly, then I know there's no fraction, it's just K times, okay? All right. Then what do I do? Now I'm gonna solve for K, so what goes where?
64.
And so that ends up being a 4, so what'd you get for K?
16.
K is equal to 16, very good. So now I'll rewrite my equation. So now my equation is S equals 16 times T squared. So now it shows me how the skydiver's distance is related to time. Okay. Everybody, so far so good? And then, you know how it works, it'll do, you get the different parts on the problem. All right. How far will a skydiver fall in 4.5 seconds? And that's a plug and crank. So you plug in your 4.5, but remember you gotta square it, and 324 feet. Might be information that they wanna know, right? Because think about the guys, this is not with the parachute, right? This is before they use the parachute. So you would know that, some of them do where they jump off of the mountains, and I guess they do like those, whatever you call that.
Like the base jump?
Base jumping, yeah. So then they know, but some of them have these crazy suits, right, that they fly around in, which I think is crazy. But anyways, if you're just going straight down, then all right, well, I got about 4.5 seconds, I've gone 300 feet. If you're 1,000 feet up, you don't have much time, right? I mean, you gotta pull that chute, okay? Okay. Are we getting how do you feel? Is we getting the last thing they may ask you to do is, let's just say, V varies jointly with G and M. G and the square of M. Let's just say that's it. What would that equation look like? V varies jointly with G and the square of M. What would that be? G and the square of M. So that would be M squared. And then it may say solve for G. So it may just want you to solve for one of these. Well, then it's easy. You just move everything over and leave the G here. So then if it says solve for G, you would do V over, KM squared equals G. Everybody with me on that? If it asks you to do that, I'm just foreseeing what it might ask. I think you're gonna be okay. I don't think it's that bad. All right, just go through them. What are the 3 words? Directly, you just do what? What do you do? K times whatever. Inversely, you do what? K over. Jointly, you do K times. Directly, jointly, and inversely, what would happen? K. So let's just say Y varies directly with X. So directly with X, jointly with W and Z, and inversely, I'm running out of the alphabet, with T. So if I had all that in one problem, we vary directly with X, jointly with W and Z, and inversely with T, what would it be? Y equals K times X times W times Z. It's just saying both of those are just multiplied. And then what? There you go. You got it now. That's it. Oh, it's exhausting. Okay. You got the words, okay? All right. I think you're good with it. Okay, I'm gonna stop this.